Now is it okay, my voice? Are you hearing me? Yes. Now tell me, which are reactants, which are products? Tejaswini. Give me reactants.
Left side are reactants, right side are products.
Okay. Don't know names. Left side.
Aluminium, iron.
Oxide. Okay. Aluminium and iron oxide. What are the products?
Aluminium oxide and iron.
Okay. Here, I know the reactants and I know the products, right? Then here, I need to calculate the masses. I need to calculate the masses. How many grams of aluminum reacting with iron oxide? So before checking that, I need to calculate. That means counting of atoms. Is it a balanced equation or not? First step is check your equation is balanced one or not. Right here, you are asked in this question. Suppose you are asked to calculate the amount of aluminum required to get 1120 kgs of iron by the reaction. Right, the reaction is given here: aluminum and iron oxide reaction to produce aluminum oxide and iron. Here, what amount of aluminum is reacting? What amount of iron is producing? That we need to calculate everything. So for that, here I need to know the atomic weights of the atoms participated individually. Before that, is it balanced one? Is it a balanced chemical equation? Answer me. Is it a balanced equation? Checking. Whether it is balanced equation or not. Here, no, it is not a balanced equation. Then what to do? We have to make it balance. How do we balance? Right? The first step is it balanced one or not? If not balanced, we have to balance that equation. So here, drop the equation here, then make it balance first. So we need 2 ice coefficient before aluminum, because I have right side 2 aluminum atoms. So put 2 ice coefficient before aluminum. Okay, aluminum solved. Then iron, left side 2 there, right side only 1 there. Make it balance. So now the equation is balanced. Then calculate atomic weights individually. So 2 ice coefficient is there before aluminum. Then aluminum weight is 27 units. So 2 into 27 units. 2 is coefficient and 27 is the atomic weight of aluminum. Is it clear what I am writing? Are you following me? Here 2 is coefficient and aluminum weight is given here is 27 units. I am substituting, nothing I am doing, right? Then plus Fe2, 2 Fe, 2 atoms of iron. So 2 subscript that I am writing as coefficient here, and 56 is the atomic weight of iron. Next, that formula unit consisting 2 iron atoms and 3 oxygen atoms together, plus. So plus I am using between them, and the 3 oxygens, 3 into 16. Is it clear? Is it clear? Right. So whatever it may be, the subscript is there, that you need to write as coefficient while calculating atomic weights of formula units. Coefficient to subscript, that can be written as multiplier. Then product side. Here 2 is coefficient before aluminum into 27 written, right? plus 3 into oxygen, 3 into 16, plus 2 Fe, 2 into 27, sorry, 56, 2 into 56, right? Then 27 2 times 54, 2 into 56, 100. So totally, right? Here 102 into 56. What you will get? 112. 3 into 16, what you will get? 48. So both together, they are taken as here. They are taken as here 160. Are you clear how I got 160 here? Are you clear? Some of these solved, right? Okay, then we'll go over product side here. On product side, 27 2 times is 54 and 3 times 16 is 48. Together we will get 102 plus 56 2 times is 112. Then take the sum of 160 and 54. It is 214 grams. Right side 102 plus 112. See here, before the change, after the change, reactants mass and products mass giving you the same value or different value? Giving you the same value or different value? Same value, right? So it is now said to be balanced chemical equation satisfying the law of conservation of mass. Law of conservation of mass. If you get different values, your equation said to be unbalanced. Remember that. If you are getting the different values at the end, right, that equation said to be unbalanced. Are you clear about this? The first step is getting that masses, right? So understand this one, how to get the masses or calculate the masses, right? Then we will go for what asked in the question. Can anybody help me? Here, look at in the question, it is asked, see here, calculate the amount of aluminum required, right, to get iron, which is product, which is reactant here. Are the reactants or products? Tell me what are asked here. One is here required, so reactant. To get means produce or product. Are you clear? Reactant to product relation is given. Reactant to product relation is given. Identifying relation must from the question only, right? Here they are asked to calculate the amount of aluminum required. So left side to right side, aluminum to iron asked. So this is our relation. Just leave that. No need. No need. Finally, what to what? That is important. So aluminum to iron. That's it. Don't go for any other. Then observe original reaction. Aluminum and iron. So how many grams of aluminum reacted in the reaction as per your balanced equation? Answer me. Unmute. Anyone? Unmute and answer. Talk to me. How many grams of aluminum participated in the reaction as per your balanced equation?
54 grams.
How many grams of iron produced?
112.
112, right? So if you got clarity here, then your problem solved. Law of constant proportion we will follow. Identifying relation is important. So as per balanced equation, look at here, 54 grams of aluminum, right? Relation is aluminum to iron. Relation is aluminum to iron. Then how many grams of aluminum participated? Note down here. 54 grams. How many grams of iron produced here? That is 112. So note down them. Drop it from the equation only. Right? Look at them again. 54 grams dropped into the relation and 112 dropped from the given equation only. Nothing I changed. Is for the balanced equation. I identified the relation. Aluminum to the iron. Aluminum 54 grams participated and producing 112 grams. Then what I want actually? Amount of aluminum required. Right? I don't know the amount of aluminum required. So I will take that as X grams. Right? Or the required quantity is X. No need to take that grams. You will get it. Right? Don't take it as grams. Directly X is the amount of aluminum required. For what? To produce. To produce. How many grams or kgs? It is 1120 kgs. Clarity vachinda relation. Clarity vachinda relation. I used original reaction first and I observed the question again. First, relation is important. If you got relation what to what, right, from whom to whom, then easy to track your problem, right? Required, so left side, produced, right side. Okay, so that I noted. Then what to do? Just take the cross product size equal. Why? Law of constant proportion. The ratios are same before and after. So any ratio is same. Suppose A by B equal to C by D is there. Ratios are equal. Then what will take? Their cross products are equal. So A into D equal to B into C mathematically. So that logic I am following directly. This step I am using. Right? Directly I am using AD equal to BC. Clear mathematical process. Ratios are equal. Cross products are equal. Any confusion? Mathematical process, right? So we will follow mathematical process after identifying the relation. That are what here? Cross products are equal, right? X into 112. X into 112. Cross product. See here. X to 112. 1120 to 54. Right? So X into, no need to take grams here. X into 112 is equal to 54 into 1120 or 1120 into 54, right? Kgs. Then I want X. So take that X left side, remaining all right side. So transpose, which not required on left side. So 112 transpose towards right side. Transposed. Look at that. Here left side multiplier, right side will be written as divisor. So transposed. Then what to do? Make it cancel. Right? Make it cancel. So here grams cancelled. Grams cancelled. Then what is remaining here? Kgs remaining. 112 10 times is 1120. So what is remained here? 54 into 10. So what I will get? X is equal to what I got? 540 kgs. 54 into 10, 540. Are you clear? Are you clear? The transposing everything, law of constant proportion, right? So I got 540. What is 540? X. What is X? What is X here? What I am taken here in the relation? X. What the X is taken?
Aluminium.
Required quantity of aluminum. What quantity I got? What quantity I got? 540 kgs. Shall we check the ratio? Right here, I will check the ratio. Look at here. simply according to your balanced chemical equation, aluminum participated 54 grams, right? 54 grams. Then produced aluminum quantities 112. 112. This is the ratio as per your balanced equation. I changed the quantity. What I changed here, aluminum changed to 540, right? Produced. Then, sorry, here aluminum written, iron it is. Then iron 1120. So what is the ratio? See, cancel. Kgs cancel, 0, 0 cancel. What is left? 54 by 112 again. Did you got clarity? Law of constant proportion. Law of constant proportion verified or not? The production also in the same ratio, never changes. Whatever it may be the quantity you are given, it won't react. With a certain amount, as per the ratio only, it will react and produce. మీరు ఎక్కువ ఇచ్చేసారు అని చెప్పేసి తీసేసుకొని ఎక్కువ ప్రొడక్షన్ ఇస్తా అంటే మనము రియాక్టెంట్స్ ని కలెక్ట్ చేయాల్సిన అవసరం లేదు. 1 గ్రామ్ ఉన్నా సరే 540 గ్రామ్స్ ప్రొడ్యూస్ చేయొచ్చు. పాసిబుల్ అవుతుంది అది. మిల్క్ 1 కప్ తీసుకొని 10 cups ఆఫ్ టీ ప్రిపేర్ చేయండి, మరి రేషియో డిఫరెంట్ అయితే పాసిబుల్? వాజ్ ఇట్ పాసిబుల్? ఇంపాసిబుల్. That ratio always same, otherwise quality damages. Maybe you will get quantity, but quality changes. అర్థమైందా? క్లారిటీ వచ్చిందా? లా ఆఫ్ కాన్స్టెంట్ ప్రపోర్షన్ అనేది ఎందుకు ఇంపార్టెంట్? ఫర్ క్వాలిటీ. లేదు అంటే క్వాంటిటీ ఫుల్గా వస్తుంది, బట్ క్వాలిటీ పోతుంది. ఇది అర్థమైతే లా ఆఫ్ కాన్స్టెంట్ ప్రపోర్షన్ వచ్చినట్టే. ఓకే, సో లా ఆఫ్ కాన్స్టెంట్ ప్రపోర్షన్ వెరిఫై అయిందా కాలేదు? ఇక్కడ ఇంకా ఏమైనా డౌట్ ఉందా? డూ యూ హ్యావ్ ఎనీ డౌట్? లా ఆఫ్ కాన్స్టెంట్ ప్రపోర్షన్ ఎట్లుంటుందో తెలిసిందా? లా ఆఫ్ కాన్స్టెంట్ ప్రపోర్షన్ ఇంకేమైనా డౌట్ ఉందా? ఏది ఉన్నా అడగొచ్చు. ఇది వస్తే నెక్స్ట్ 2 ప్రాబ్లమ్స్ వెరీ ఈజీ. ఇక్కడ ఓన్లీ మాస్ మాత్రమే క్యాలిక్యులేట్ చేసినాం. ఇన్ ద నెక్స్ట్ ప్రాబ్లమ్ వి విల్ క్యాలిక్యులేట్ మాలిక్యూల్స్, వాల్యూమ్, ఎవ్రీథింగ్. Right? Shall I go to next problem? Shall I go to next problem? Yes. Right? Now see the second problem here. Example 2 is asked like this. So I got 540 kgs, right, to produce 1120 kgs of iron. 540 kgs of aluminum required to get 1120 kgs of iron. So this is the solution. Then we'll go for example 2 here. Example 2 question is asked like this. What is calculate volume, mass and number of molecules of hydrogen liberated when 230 grams of sodium reacting with excessive water. Tell me which are reactants here. Anybody? Especially 10th class students. First preference, 10th students. Rohit, which are reactants here? What are reactants? Can you identify? Can you identify reactants? Read the question, understand. Harshit? No idea? Read again. Calculate the volume, mass and number.
Sodium and water.
Come again.
Sodium and water.
Very good. Sodium and water.
H2.
Two are reactants. What is the symbol of sodium?
Na.
What is the formula of water?
H2.
Right? H2O. So here atomic weights are given in the problem. As Na equal to 23, O equal to 16, H equal to 1. If not given, what to do? Just make it double. Atomic number, make it double. You will get that. Sometimes it may be different, but no importance to that. Right? No importance to that. Some variation is there because of neutrons count is different. Okay. So make it double, approximately you will get the same answer. They will give you full marks, no doubt in it, right? Then here reaction, what? Sodium reaction with water. This equation not given. Then what are the products? What are the products? Here products, without a given chemical equation, I am writing chemical equation. So what I am here, this splitting into ions. So Na produces Na plus ion, H2O give you H plus and OH minus ions. I is for your 9th class knowledge, crisscross method, splitting into ions, right? So here Na combination with NaOH, right? Plus and minus. Then hydrogen ice itself molecule produces, right? So that we can write ice equation here. Then reaction produces NaOH and liberation of gas. So this is the reaction. So H2 is what? Gas liberated. So we can use one symbol beside it. What the symbol? Not G actually. We have to write upward arrow to indicate liberation of gas. Are you clear how I am written the equation without remembering? Follow your 9th class knowledge, crisscross method, radicals, writing the radicals, splitting ions, right? Once refer the 9th class book. Sometimes they may ask you without giving you the reaction equation, right? Just they will give you reaction. Okay, so try to solve these type of questions also. Okay, I got. Then what is your solution? First of all, check that equation is balanced one or not. Is it a balanced equation? Is it a balanced equation? Answer me.
No, sir.
We have to make it balanced first, right? So Na plus H2O useless to NaOH plus H2 gas. Okay. Here the problem with hydrogen atoms. No problem. Oxygen atoms. No problem. Sodium atoms. Sorry, there is a problem in hydrogen gas. Spelling, sir, that mistake. I did a mistake. What is here? Hydrogen gas, symbolically it is 2. Right? There is a problem in the hydrogen atoms. There is a problem in the hydrogen atoms. So right side I have 3 atoms. Left side I have only 2 atoms. Then make it balance. Right? Put symbol, okay, 2 ice coefficient before H2O. Then I got count ice 4. So how to solve right side? Selecting 2 ice coefficient before NaOH. Then Na count is changed. Make it balance by writing 2 ice coefficient before Na. Now it is balanced chemical equation. Then what to do? Calculating the atomic masses. 2 into Na 23 plus 2 into here coefficient is there, subscript there. So if you get coefficient and subscript both, what to do here? Just you follow one logic. Coefficient separate with a bracket like this. Use your distributive property. So 2 into 2 is the subscript of hydrogen. So 2 into its atomic weight 1 plus no subscript for oxygen. So 1 into 16, 16 only written. Right? That is here 2 into 1 plus 1 into 16 H2O. 2 into again coefficient for different atoms. So start in the bracket first. Okay, different bracket. So 2 into 23 plus 16. 1 into 16 plus 1 into 1. So 16 plus 1. O plus H. O is 16. H is 1. 16 plus 1 plus 2 is subscript. So take it as coefficient 2 into 1. Are you clear about that substitution? Are you clear? Yes. Then solve it. 2 into 23, 46. Then first in the bracket, 2 into 1 is 2. 1 into 16 is 16. So 2 plus 16 is 18. 18 2 times is 16. Sricharan,
Sir,
What is your confusion?
sir, NaOH లో మళ్ళీ 2 into 23 అని రాశారు సార్ మీరు.
Okay, mistake. Sorry. Thank you. Here it is the mistake. Only 23. Thank you. Very good. Then right side in the bracket 23 plus 17. What I will get? 40. 40 into 2, 80. Plus 2 into 1 is 2. So left side 46 plus 36. How much totally? 82 grams. Right side 80 plus 2, 82. So I got equally. So my balanced equation is correct and I calculated correctly. There is no mistake, right? So this like you have to verify first before starting the solution, right? Rough work. Then identifying the relation. Can anybody identify the relation here? Anybody? Again, go to the question to identify the relation. What to what? What to what? Anyone? Identify the relation. Relation only important. According to your balanced chemical equation. Relation. What to what? Read the question. Hydrogen liberated when 230 grams of sodium react with excess water. So maybe you are in confusion, sir. Here in the previous example, only one reactant is given, sir. Now 2 reactants mentioned, sir. Don't worry. Here, any importance of water? Any importance of water? Did they given mass of reactant H2O in the question? No. It is just given as excessive amount. Whatever it may be the amount you are providing, the reaction takes place as per the law of constant proportion, same ratio between the masses. So here no importance to the water. Then what are left here? 230 grams of sodium and production hydrogen. So sodium to hydrogen relation is given. So you are taking sodium and hydrogen, right? You are taking sodium and hydrogen as your relation here. Okay, then what to do? Take the masses as per your balanced equation. So how many grams of sodium participated in the reaction? Can anybody answer me immediately? Don't waste the time. Unmute and answer me. How many grams of sodium participated in the reaction? Come again.
46 grams.
46 grams. So then drop. How many grams of hydrogen liberated as per balanced equation?
2 grams.
Drop it. So 2 grams of hydrogen. Then what the quantities are changed in the question? Sodium quantity changed. How many grams given? 230 grams. Then asked to find out liberated gas. So question mark 2, hydrogen. Don't know. No need to take the grams as X unknown quantity. That's it. Then what to do? Take the cross products are equal. Cross products are equal. So here law of constant proportion we are following. As per that law of constant proportion, I am writing cross products are equal. So X into 46 is equal to 2 into 230 or 230 into 2. Anything you can take. A into B equal to B into A. So 230 into 2. Right? Then just send unwanted, the quantity which you are not required. The quantity which you are not required. Right? So this is I am not required here. So transposing towards right side. So transpose it. Left side multiplier, right side divisor. So I got X equal to 230 into 2 by 46. Then make it cancel. So here 2 into 23 is 46. Right? So here 46 using 2 table. Okay. 2 1 time, 2 23 times, then 23 10 times. So what is left here? 10. X equal to what? 10 grams. So I required here, sorry, I am not required, produced here, how many grams? How many grams? 10 grams. So here in the reaction, you are produced 10 grams of hydrogen by the 230 grams of sodium reaction with excessive amount of water. Excessive amount of water. So have you got clarity in this? Are there clarity? Any confusion? So this is first step, is important to find out the volume and molecules. Mass is compulsory. By the mass only you will calculate mass and molecules. Whose mass, whose molecules, whose volume? Hydrogen. Liberated hydrogen, right? So I got the quantity of hydrogen 10 grams, right? Then we will go for finding molecules and volume, right? Finding molecules and volume here. So I will note down that 230 grams of sodium producing 10 grams of hydrogen here. Okay, noted. Here, as per your balanced equation, how many grams is equal to 1 mole? What the coefficients are there before your balanced chemical equation? See here, 2 sodium atoms, 2 water molecules, and 2 sodium hydroxide. So this is your balanced equation. So here coefficient before the pharma unit indicating number of moles, 2 moles, 2 moles, 2 moles. Here nothing is there, 1 mole, as per balanced equation only. So how many moles of hydrogen liberated as per balanced equation? 1 mole. What is atomic weight? Calculated 2 grams. So here 2 grams is 1 mole. 2 grams is 1 mole. So 1 gram molar mass is equal to 2 grams of hydrogen. So here 2 grams of hydrogen occupies 22.4 liters of volume at a standard temperature and pressure, that is 273 degree Kelvin, 1 bar. At that pressure and temperature, it is occupying 22.4 liters of volume. Then 10 grams of hydrogen occupies what? Don't know, unknown quantity, Y liters. Unknown quantity, it is maybe Y liters. So what is Y? I need to find out. So again here I am following the same, only hydrogen. According to balanced equation, 2 grams is 1 mole, 2 grams is 1 mole, right? It is occupying 22.4 liters. Then what about 10 grams of hydrogen? Quantity varying, volume also changes. Mass changed, volume changes, right? Then take it here. So 10 grams is Y liters. I don't know. Then I will follow the same law of constant proportion. Cross products are equal. That cross products here, Y into 2 is equal to 22.4 into 10. So that I am written. Any confusion left here? I am following the same law of constant proportion here. Any confusion? Are there any confusion? No confusion. Okay. Then here cross products are same. So unknown quantity or not required quantity transposing right side. So transpose it. Transposed. Then make it cancel. So here 22.4 cancel because 10 easy to multiply. So what is that? 11.2. So 11.2 into 10, it is 112. So Y equal to, I got 112 liters, not grams, not grams. Y equal to 112. So this is mistake, typing mistake. So Y equal to, I got 112. So what we can write here, simply to produce, 10 grams of hydrogen is produced. That 10 grams of hydrogen occupies 112 liters of volume. Was it clear? Any confusion? Are you clear? Right. So one more is there to find out in this question only, that is number of molecules. Just join immediately. I will explain you that also, right? This time completed, meeting time. So join again. We will complete this second lesson today. Join immediately.